Astronomers might have found something cool with that fancy new telescope, the one that costs like $10 billion. But even if everything goes smoothly, it'll take years to confirm anything. Getting to Proxima b would take around 20 years, so realistically we're talking decades before we know if there's life there. That big question, are we alone, keeps popping up. The James Webb Telescope might have spotted some freaky but human-like stuff way out there, inching us closer to an answer. We've been obsessed with finding alien life for ages. Just look at all the books, movies, and theories about it. We always wonder what our place is in this huge empty universe, like we're programmed to find a buddy no matter how weird. Back in 2021, when they launched the James Webb Space Telescope, someone asked if we'd ever be able to spot artificial light on other planets like Proxima b. It's the closest exoplanet and sits in the habitable zone of Proxima Centauri, a dwarf star about 4.25 light-years away. Because Proxima b is so close to its star, people thought it was tidally locked with one side always facing the star like our moon. Some theorized a tech civilization there might move heat and power from the sunny side to the dark side using solar panels. A study even showed that enough solar panels could be spotted by future telescopes. Now in 2024, it seems the James Webb Telescope might have done exactly that. Its sensitivity and power might have detected those lights, which could send us into a new period of growth. But first, let's talk about planets and exoplanets to explain how this is possible. Planets, exoplanets, and the search for life. For ages, people have wondered about the universe, where we come from, where we're going. They're tough questions, but now with all this tech bouncing around, are we any closer to answering them? A philosopher might say we're still clueless, but ask an astronomer and they'll practically explode with excitement, telling you about the latest discovery humans made using our high-tech tools. These things might not get much attention, but they're a sign of how far we've come. We're starting to understand how to work the universe, and that's because of something special we built. Yep, the James Webb Space Telescope. It's the result of human space dreams built to solve those big mysteries. Are we alone? Who's out there? Where did everything come from? It's already helping. Proxima b is an exoplanet, a planet outside our solar system, and a super-Earth, meaning it's bigger than Earth, but smaller than ice giants like Neptune. These can be gas rock or both, and they can be huge, up to 10 times Earth's mass. Proxima b orbits an M-type star. To understand that, you need to know about red dwarfs, the smallest and most common stars near our Sun. They're not bright, so they're hard to spot. They come in types based on temperature and size. Proxima b is about 1.07 times the mass of Earth. It zooms around its star in just 11.2 days. The star itself is tiny, about 0.16% the luminosity of our Sun. Most of its energy is infrared radiation. Discovered in 2016, Proxima b caused a fuss because it orbits the closest star to our Sun. In cosmic terms, 4.25 light-years is nothing. It's part of the Alpha Centauri triple star system and is possibly in the habitable zone. Humans are nosy, so we created SETI, the search for extraterrestrial intelligence. Imagine God setting up a cosmic treasure hunt, but instead of gold, we hunt for signals from other civilizations. Back in the early 1900s, guys like Tesla and Marconi thought about using radio to reach out to the stars. Tesla even dreamed of talking to Martians. In the 60s, Frank Drake started Project Ozma, scanning the skies for signals. He found none. Then came the wow signal, a weird blip that sent the science world spinning. The search continued. The Soviet Union, led by Zdenek Slavy, also joined the hunt. Then came a coded radio signal from Mars. In 2021, a research paper asked if we could spot artificial lights from Proxima b. Could it support intelligent life? And how would we know? They pointed to a weird radio signal coming from Proxima b's direction, not recent, but it rocked the science world. The Breakthrough Listen project detected a signal at 982 MHz, a frequency used on Earth. This opened the door to exciting possibilities. Tests were run, but no clear conclusions came. The team suggested Proxima b always faces dark, and artificial lights could be the key. Simulations showed telescopes would have an 85% chance of detecting artificial lights that made up just 5% of the planet's surface, huge for discovery. Neil deGrasse Tyson explained the science. How can we do these crazy calculations? Not long ago, reaching the moon seemed impossible. Now we're analyzing planets light-years away. Thanks to tools like JWST, we can study planetary atmospheres. Its infrared sensors detect gases like oxygen, methane, and carbon dioxide, biosignatures often produced by life. JWST also detects light from distant worlds, either reflected from a host star or emitted as infrared radiation. This helps scientists study surface conditions, weather patterns, and atmospheric composition. JWST isn't just for finding planets, it helps us understand how they form. That's crucial for learning what makes a planet habitable. By studying stellar nurseries and young systems, it could reveal how our own solar system was born. SETI has evolved. It's not just about radio signals anymore. Scientists now consider the possibility of alien tech we can't yet detect or civilizations too advanced for our tools. One bold idea: detecting artificial light. If aliens use lighting for energy or agriculture, we might spot it. It's theoretical but promising. Space exploration now pulls in biologists, chemists, engineers, and more. Biologists help identify alien environments, chemists look for life indicating molecules, engineers build better telescopes. Despite the hurdles, the future of space exploration is bright. With tools like JWST, we're closer than ever to answering humanity's biggest questions. Whether or not we find life, the journey itself pushes technology and deepens our understanding. New missions like NASA's Europa Clipper will explore promising environments in our own solar system. The search isn't just about aliens, it's about understanding ourselves and our fragile Earth. Let's say the lights on Proxima b aren't natural. Let's say they're really artificial. That means someone or something is out there powering their world in the dark, maybe staring up at their red sun and wondering the same thing we do. Are we alone? That's the paradox. We build these insane machines to look farther than ever before, but we don't really know how to handle what we might find. Discovery means rewriting everything: science, religion, politics, even how we see ourselves. It won't be like in the movies. There might not be flying saucers or interstellar greetings, but there could be a transmission. A pattern in the light. A signal, unmistakably unnatural. Stephen Hawking once warned us if aliens visit Earth, the outcome might be similar to when Columbus landed in America, which didn't turn out well for the natives. That's the thing: if a civilization can broadcast across light years, they're way ahead of us. We're talking about technology that might manipulate energy, space, even time. Some scientists argue we should only listen, not send anything out. Others say it's too late. Our TV broadcasts radio signals, even early radar pulses have already leaked into space, a bubble of human noise stretching 100 light-years wide. That's why we look up. That's why we build space telescopes and fund billion-dollar missions. It's not just science, it's existential. We need to know if we're special or just one story in a library of civilizations. Some philosophers argue that the very act of searching reshapes humanity. It forces us to think long-term, beyond borders and petty politics. It asks us to see Earth as one place, not a fractured mess. It might show us how to survive longer than a few thousand years, how to balance tech with nature, or how to avoid the mistakes that end civilizations before they ever get a chance to reach the stars. JWST is just the beginning. NASA, ESA, and other agencies are planning even more powerful telescopes like the Habitable Worlds Observatory and LUVOIR. These will make JWST look like a pair of binoculars. And then there's Breakthrough Starshot, a wild project aiming to send micro spacecraft to Alpha Centauri at 20% the speed of light, tiny ships riding on laser beams. If it works, we could reach Proxima b in just over 20 years. So here we are watching faint flickers of infrared light from a planet 25 trillion miles away, wondering if someone's home. We crossed oceans, split atoms, landed on the moon, and now we're reaching across the stars. Maybe we won't find life on Proxima b, maybe not this year, maybe not this century.